Previous year question and answer solution of Stream Electronics and Communication Engineering. Subject: Digital Image and Video Processing. 5 marks, short question. Question 1. Explain one motion estimation technique. Answer: Motion estimation technique. Block matching algorithm. BMA. 1. Definition. Block matching algorithm, BMA, is a motion estimation method where each frame is divided into fixed size blocks, typically 16 by 16 pixels, and each block is searched in the previous frame to find the best matching block, giving a motion vector. 2. Working principle. Divide current frame into blocks. For each block, search within a search window in the previous frame. Compute a matching criterion, for example, MSE or MAD, to measure similarity. The displacement giving minimum error is selected as the motion vector. 3. Formula. Matching criterion. For a block of size n times n, MSE of x, y equals 1 over n squared, summation I equals 0 to n minus 1, summation j equals 0 to n minus 1, open bracket, ik of I, j minus ik minus 1 of I plus x, j plus y, close bracket, squared. The vector, open parenthesis, x, y, close parenthesis, that gives minimum MSE becomes the best match. 4. Diagram description, text form. A current block in frame K is compared with several candidate blocks inside a square search window in frame K-1. The candidate block with minimum error gives the motion vector, arrow from current block to matching block. 5. Types of search strategies. Full search. Checks all candidates. Accurate but slow. 3-step search. Reduces comparisons in 3 iterations for fast estimation. 6. Advantages. Simple and hardware friendly. Used in MPEG/H.26x standards. Works well for translational motion. 7. Limitations. High computational cost for full search. Performance drops for non-rigid or complex motion. Question 2. Define 4 adjacency, 8 adjacency with proper example. Answer. 1. Definition of 4 adjacency. 2 pixels P and Q with intensity values from set V are said to be 4 adjacent if Q belongs to N4 of P. N4 P-4 neighbors. For a pixel P, open parenthesis, x, y, close parenthesis, the 4 neighbors are, open parenthesis, x plus 1, y, close parenthesis, open parenthesis, x minus 1, y, close parenthesis, open parenthesis, x, y plus 1, close parenthesis, open parenthesis, x, y minus 1, close parenthesis. Example. Open parenthesis, text diagram, close parenthesis. Consider pixel P at, open parenthesis, 2, 2, close parenthesis, open parenthesis, 2, 1, close parenthesis, open parenthesis, 1, 2, close parenthesis. P, open parenthesis, 3, 2, close parenthesis, open parenthesis, 2, 3, close parenthesis. Only these 4 pixels are 4 adjacent to P. 2 pixels P and Q with values from V are 8 adjacent if Q is in N8 of P. N8 of P. 8 neighbors includes 4 neighbors plus 4 diagonal neighbors. Diagonals x plus 1, y plus 1, x plus 1, y minus 1, x minus 1, y plus 1, x minus 1, y minus 1, y plus 1, x minus 1, y minus 1. Example: text diagram. For pixel P at 2, 2, 1, 1, 2, 1, 3, 1, 1, 2, P, 3, 2, 1, 3, 2, 3, 3. All 8 surrounding pixels are 8 adjacent to P. 3. Key difference. 4 adjacency. Only horizontal plus vertical neighbors. 8 adjacency. Horizontal plus vertical plus diagonal neighbors. This affects connectivity and number of possible paths between pixels. Also noted in notes, 8 adjacency gives multiple paths. 4. Diagram description. 4 adjacency. Plus-shaped neighborhood. 8 adjacency. Square-shaped neighborhood around the pixel. Question 3. 8 directional chain code of an object is given as 788 7703 12. What is the perimeter of the object? Hint: even count plus square root of 2 odd count. Answer: 1. Understanding the chain code. In an 8-directional chain code, each number represents a direction in a grid. 0 equals right. 1 equals upright. 2 equals up. 3 equals up left. 4 equals left. 5 equals down left. 6 equals down. 7 equals down right. 8 equals diagonal. 2. Given chain code. The given chain code is 788 7703 123. Counting directions. Even directions. Horizontal or vertical. These are the directions 0, 2, 4, and 6. Even count. Directions 7, 7, 7. All odd. Even count equals 0. Odd directions. Diagonal. These are the directions 1, 3, 5, and 7. Odd count. Directions 7, 8, 8, 7, 7, 3, 1, 2. Odd count equals 3. 4. Formula for perimeter. Perimeter equals even count plus square root of 2 times odd count. 5. Substituting the values. Even count equals 0. Odd count equals 3. Thus, the perimeter of the object is perimeter equals 0 plus square root of 2 times 3 equals 3 square root of 2, approximately 4.24. Final answer. The perimeter of the object is approximately 4.24 units. Question 4. A video has one frame of size 640 by 480 with 3 bytes per pixel. It is assumed that the video is taken at 30 frames per second. What is the storage and transmission requirement at a rate of 64 kilobits per second? Answer: 1. Given data frame size 640 by 480, bytes per pixel 3 bytes, frames per second FPS 30 FPS, transmission rate 64 kilobits per second. 2. Storage and transmission requirement calculation. Storage requirement per frame. To calculate the storage requirement per frame, storage per frame equals frame size times bytes per pixel. Pixel equals 640 times 480 times 3. Storage per frame equals 921,600 times 30 equals 921.6 kilobytes. Storage requirement per second. Since the video has 30 frames per second, storage per second equals storage per frame times frames per second. Storage per second equals 921,600 times 30 equals 27,648,000 bytes equals 27.648 megabytes. Transmission requirement. At a rate of 64 kilobits per second, we convert the storage per second into bits. Transmission requirement equals 64 kilobits per second equals 64,000 bits per second. Now, to determine how much data is transmitted per second for a 640 by 480 frame at 30 frames per second, we calculate the total bits required per frame. Total bits per frame equals 640 times 480 times 3 times 8 equals 7,372,800 bits. Now, frames per second is 30. Total bits per second equals 7,372,800 times 30 equals 221,184,000 bits per second equals 221.184 megabits per second. The transmission rate of 64 kilobits per second is much lower than the required rate of 221.184 megabits per second for real-time video at 30 frames per second with the given resolution and color depth. Final answer. Storage requirement per second equals 27.648 megabytes. Transmission requirement per second equals 221.184 megabits per second, far higher than 64 kilobits per second. Question 5. Explain any one method of color image segmentation. Answer. Color image segmentation, region growing method. 1. Definition. Region growing is a region-based segmentation method where the image is divided into regions by grouping adjacent pixels that have similar properties, such as color, texture, or intensity. It starts with seed points, initial pixels, and progressively includes neighboring pixels that meet a similarity criterion. 2. Working principle. Step 1. Selection of seed points. Seed points are chosen manually or automatically based on specific features, for example, pixels with a specific color or intensity. Step 2. Growing the region. Starting from the seed point, neighboring pixels are examined. If they meet the similarity criterion, for example, similar color values, they are added to the region. Step 3. Iteration. The process continues iteratively, expanding the region until no more pixels meet the criteria for inclusion. 3. Example. Suppose we have an image of a colored object, for example, a red apple, on a contrasting background. If we choose a seed point on the red area and use the RGB color similarity criterion, the region will grow to include all adjacent red pixels, thereby segmenting the apple from the background. 4. Diagram description. Initial seed point. A single pixel is selected as the seed. Region expansion. Neighboring pixels with similar color values are grouped into the same region, creating a connected component. Final result. The object, for example, red apple, is segmented, and the region is clearly defined. 5. Advantages. Simple and effective for segmenting regions with homogeneous color. Adaptive to varying image conditions based on selected criteria. 6. Limitations. Sensitive to initial seed point selection. Poor seed points may lead to inaccurate segmentation. May struggle with highly textured or noisy images.